We've all heard the story. Isaac Newton sees an apple fall from a tree. This simple thing makes him think, could the same force that pulls the apple down also keep the moon going around the Earth? Newton's law of universal gravitation, which he figured out in 1687, explains this force. It says that everything in the universe pulls on everything else. The strength of this pull depends on how heavy the objects are and how far apart they are. Newton's theory was a big deal. It explained how planets move, why we have tides, and why things fall down. For hundreds of years it was the main way we understood the universe. It let us predict how things move in space really well. But as we learned more, we started to see some problems with this theory. Things we saw in space, like how galaxies spin, couldn't be explained just by Newton's laws. So scientists started looking for a better explanation of gravity, one that could explain these mysteries. We're still looking for that better understanding today. As we looked further into space, we found things that challenged Newton's laws. The speed of spinning galaxies was a big puzzle. Stars on the outer edges were moving way too fast. This made scientists think there must be something we can't see, called dark matter, that's adding extra gravity to hold these galaxies together. The fact that the universe is expanding was another challenge. Instead of slowing down because of gravity, the expansion is speeding up. This suggests something called dark energy is at play. These mysterious things showed us that our old understanding of gravity wasn't enough. So, people started coming up with different theories to try and explain these things. One idea is called modified Newtonian dynamics, MOND. It suggests that Newton's laws don't work the same way when gravity is very weak. Another idea is that gravity itself might work differently at different sizes in the universe. Now let's talk about Nikola Tesla, a brilliant and unusual inventor. Tesla, famous for his work on the kind of electricity we use every day, AC electricity, was also interested in gravity. He disagreed with the usual ideas and had a very different way of thinking about this force. Tesla's theory focused on something called the ether, a substance he believed fills all of space. He thought this ether was always moving and interacted with objects, creating gravity. Tesla said that objects aren't pulled together by a mysterious force from far away, but are pushed together by forces within this ether. He even thought gravity might be connected to electromagnetism, another important force in nature. Even though there's no real proof, Tesla's ideas are still interesting to scientists today. What if the air we breathe plays a part in gravity? The atmosphere, the layer of gas around our planet, pushes on everything. This push, called atmospheric pressure, gets weaker the higher you go. Some people believe that what we feel as gravity might be at least partly because of this air pressure. This idea says that objects aren't just pulled down by the Earth, but are also pushed down by the weight of the air above them. Think about it. When something is in water, it feels an upward force called buoyancy. Could the atmosphere be like water and the downward force we feel is just buoyancy and pressure working together? We've looked at gravity in many ways, from Newton's apple to Tesla's ether. We've seen accepted theories and radical new ideas. The usual model, with its reliance on things we can't see like dark matter and dark energy, has its own problems. On the other hand, unusual ideas like Tesla's dynamic gravity and the atmospheric pressure idea, while interesting, haven't been proven by experiments. Maybe the answer lies in combining these ideas. Could gravity be not just one force, but the result of many different things working together? This new way of thinking would change everything, making us rethink our models of the universe and how it has evolved. Our search to understand gravity is far from over. It encourages us to be open-minded, to question what we think we know, and to embrace the unknown. By studying this fundamental force, we might uncover secrets that could change our world and lead us to a future shaped by a deeper understanding of the cosmos.